Hello, this is Pablo Pasos from CaboLabs.com. On this video I want to show you a little weekend project that I created to work with openEHR archetypes. The idea of this small project, small tool that I created, is to generate some spreadsheets from archetypes, because I need to create some mappings with databases. So I need to extract data from some clinical databases and map that to openEHR archetypes to standardize that and to be able to store the information in our EHR server. So the EHR server is our little clinical data repository that we created to store. Is a genetic clinical data repository to store clinical data using the openEHR standard. If you don't know the openEHR standard, you can visit openEHR.org and read the specifications. It's an open standard to define and manage and evolve and interpret clinical information, so it's very useful. What I want to show you is going to be available on my GitHub account. So I really did this video because I think this code or this little tool that I created might help others. So it will be available on my GitHub account. It's just GitHub P Pasos or Pablo Pasos, and here on the openEHR ADL project you will find this code, the code that I am about to show you. So, basic idea: when you have a set of clinical data and you want to map that to something that is a standard, in the case of openEHR. openEHR has these structures that are called archetypes, that are models of clinical information based on the openEHR information model. The openEHR information model is just a generic information model to store or to manage clinical information that is very, very useful. And the way to specify which kind of structure do we want to use from that basic reference model is defined on archetypes. openEHR has a tool that is the Clinical Knowledge Manager, or CKM, where you can actually find those archetypes that define clinical structures, clinical data structures mainly. So you can find, for example, this is the basic example that we all know, blood pressure, and I like this view using a mind map to see the structure defined by this archetype. So you can use this archetype to store systolic blood pressure, diastolic blood pressure. You can, for example, the cuff size that was used to take the measurement of the blood pressure, record the method, the position of the patient at the moment of taking the measure. Yeah, so a lot of information is here. One key aspect of archetypes is you don't need to use actually all these data points. It's all optional. So you can just take the basic model and, for example, use systolic and diastolic as we do in most cases, and maybe a comment, yeah, about the measurement. Yeah, this is not the real structure. This is just a graphical representation. The structure is defined in this language that is the ADL, or Archetype Definition Language, and is like a mix of JSON and XML. It's something different, yeah, but you can think of a mix of that. It's just an unstructured format to represent these models, the clinical information models. One thing that you can see is archetypes can be translated to many languages. So Korean there, Portuguese, Arabic, English, Chinese, Spanish, blah 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 blah. Yeah, and the structure of the blood pressure is defined here. Yeah. So you can see some stuff that is familiar. For example, you can see, for example, this block represents the structure to record the systolic blood pressure. So this is just a little comment in the structure. Yeah. Then you have another structure that represents the diastolic blood pressure, and what is defined inside is really a constraint. So for example, this is saying that the diastolic blood pressure will be measured in millimeters of mercury, for example. This is the standard unit for millimeters of mercury. The magnitude, you have a range of values that are valid, and precision is the number of digits after the decimal point, basically. Yeah, this is saying there are no points after, no digits after the decimal point. Yeah, so you have an integer number. Yeah, so in case you want to use archetypes and you already have data in your database, what you need to do is to map your data with these archetypes. So you come here to the CKM, you find the archetypes that represent your concepts. Yeah, based on, for example, I have blood pressure in my database, so I will use the blood pressure archetype. Yeah, that is the concept. Then the data is inside. So I will go here to the red arrow, and you can choose between downloading ADL or XML. I choose ADL because it's easier to work with. Yeah, but XML is also valid. It's just bigger. I already downloaded many archetypes that I will work with. In fact, these archetypes are mapping to real data that I have on an application. Yeah, we are building clinical information system for emergency departments. Yeah, will be released next year, early next year. And what we are working on right now is to map all the data that we have to openEHR archetypes to be able to standardize the information, to exchange the information with other systems based on openEHR. Also, openEHR could be easily mapped to other standards like HL7 Fire, HL7 CDA, HL7 version 2, etc. Yeah, and other standards that are related to information exchange, but mainly HL7 is used for that purpose. Yeah, so we could just map to HL7 or use the openEHR formats to exchange information. That we have XML and JSON formats to exchange clinical information based on the openEHR model. Yeah, yeah. So I have this ADL files. You can see all our ADL, and those are archetypes, just similar code as the thing that I showed you a second ago. Yeah, so this is ADL. Yeah, so the idea is I already have a data model. I have these archetypes that might represent in maybe not exactly the data that I have. I need to evaluate that later, but I want to do a mapping. In general, mappings are done because it's easy to work with in spreadsheets. Yeah, so I represent on the first half of the spreadsheet the data that I have. Maybe if I'm using relational databases, what I do is I represent tables and names of columns and types of the data types that I use for each column, and then on the second half of the spreadsheet I try to map each table and column and type to one archetype node. Yeah, archetype nodes also have a concept that is similar to the table. Might be the archetype ID, for example. The name of the files are the archetype ID. Then each node inside the archetype, because the archetype is like a tree, has a path, and the path is similar to the column name, so I tend to map those. But also I need to check the types are correct. So the type of data that I have on my columns should be compatible with the type of data on one path inside an archetype. So I do those checks. Yeah, but yeah, it's difficult if to reach that spreadsheet if you don't have some plain structure to work with from the archetypes, because archetypes are mainly trees. Yeah, so they have this structure, so it's difficult to map this to a spreadsheet where you have rows and columns. Yeah, it's just a matrix. Yeah, so my idea was I will grab one of these archetypes, I will check each node there, and for each node I will generate one line, one row in a spreadsheet, and I will output that. And I thought to do that manually, and since I'm a software engineer, I choose to write a program for me to do that job, because I don't like to do repetitive jobs. And if you have 2 archetypes, maybe that's okay, but if you have 1,000 archetypes, that will not be okay. You will be working on this for the next 2 years. So that's not the idea. So what I did, let me show you some code, because software engineers like code. Yeah, this is the project. Yeah, good. So first I need to, since those are my requirements and the context to give you the full view of what I'm doing, I tried to figure out what I really wanted from the code. Yeah, I thought to generate one CSV for many archetypes. I thought to create one program that processes one archetype at a time. And I choose to create a program that you really pass a parameter that is a folder that contains many archetypes. So my idea was this, to pass this folder where I have many archetypes and to process all the archetypes in that folder. So that was my first idea. So what I did is here I am processing those parameters and I'm checking the folder I'm passing exists. Yeah, very easy. Then on this project, the openEHR ADL, that is a set of tools that I created some time ago to work with ADL and also to show others how to work with ADL in code, because most programmers that want to work with openEHR need to know this, and we do a lot of courses and workshops online. So for training purposes, I created this project, but also is useful for some tasks that I need to do on real projects. Yeah, so I created an archetype manager. What the archetype manager basically does is you can pass a path to it, a folder path that contains many archetypes, and if you call the load all method, it will load all the archetypes in memory. So it will take all the ADL files here and will parse the ADL and will generate objects in memory. So right now here I have all the archetypes as objects. Yeah, so I can do things in code to those with those archetypes. To parse and load those archetypes, I'm using I will show you that. I'm using the Java reference implementation from the openEHR Foundation. So if you go to openEHR organization in GitHub, you can see here that there is a JavaLibs project. So I'm using this project to load the archetypes in memory. The model of that archetype structure is defined on these 2 subcomponents, the openEHR AOM and the openEHR AP. Yeah, and the parser that actually uses those models to load the archetypes from files is this component, ADL parser. Yeah, you can check the code here if you want, but it's all behind the scenes if you use the archetype manager. Yeah, and then I try to realize what kind of CSV file or spreadsheet, yeah, to generate and the format. So I choose to generate a CSV file because it's easier than working directly with a spreadsheet format. Yeah, like Excel or Open OpenCalc, I think is the other file that is the open source format. So I choose CSV that could be opened on LibreOffice, OpenOffice, and Microsoft Office. So yeah, very simple. So first, my columns. So I wanted to add the archetype ID, so I know, of what concept are we talking about. Yeah, so archetype ID should be there. Path will represent each node in the tree, because the archetypes are three trees, remember that. Yeah, and each node in the archetype also refers to a type in the reference model. Remember that all the archetypes are based on the openEHR reference model. Yeah, that is a generic reference model to store information. But it's the archetype that really defines which specific structure will be used to store certain information. Yeah. Then we have the AOM type. That is the type from the archetype model. AOM means archetype object model. Yeah. So these are the types in the in those trees that are loaded in memory. Then some nodes contain a value that is the node ID. Not all the nodes have node IDs, and the nodes in the archetype that have node IDs also have certain definitions. Yeah. So if we go here, for example, family history. Yeah. You can go to the last part of the archetype. You can see definition is here, has the structure, but doesn't have any text really defining each node in the tree, but have this AT0003, AT0004. Those are the node IDs. Yeah, are these ones. But below there is an ontology section, and for each language this archetype is translated to, and each of those node IDs, they have a definition, and they have a text that is a short definition, and they have a description that is a longer definition. Yeah. And what we want to do is to take for each node that has node ID this text and put that in the CSV that we are going to generate. Yeah. So for each language, and these are dynamic columns because different archetypes could be translated to different languages. Could be translated to one language or to many languages, but at minimal just one language. So these columns are dynamic. So I need to check which languages each archetype contains, and for those languages I need to generate these columns dynamically. Yeah. So these are the columns that I will create on the CSV. So if I take the archetype manager, I already loaded the archetypes from disk. I can, with this method get loaded archetypes, I can iterate through all the archetypes that are in memory right now. Yeah, since I'm using the Groovy programming language, Groovy has this closure that allows me to iterate. Yeah, and since this is a map, what this method returns, this is a map that contains as a key the archetype ID and as a value the archetype, and the archetype is here is the object that represents the archetype that was parsed, yeah, from the file. Yeah, so here I need to create the header of each CSV, and I decided to, for each archetype on the loaded archetypes, to generate one different file. Yeah, first I thought of generating all the files in this, all the CSVs for all the archetypes in the same file, in the same CSV file, but since these columns related with the names are different on different archetypes, that didn't seem a good idea. So what I did is I broke down this generator to process each archetype independently and generate one CSV per archetype. Yeah. So I have the headers. These are the static headers, and then I need to add the language headers. So I can iterate through all the languages in the archetype just by calling ontology languages each, and each language will be here. So here I add the dynamic column names. So name and language. This will be Spanish, English, Arabic, Chinese, blah blah blah. Yeah. And then I finish the headers. So right now I have the headers for this archetype. Yeah. And then I will iterate through all the nodes in the archetype. Yeah, the archetype has a path node map. This comes from the Java reference implementation, and this contains a map that the key is the path to the node and the value is the node in the archetype. Yeah. All the nodes in this map are instances of C object. This is the constraint object defined in the archetype object model. You can check the code in the Java libs of the openEHR implementation, so to see what this is. Yeah, but it's all on the GitHub repository I just show you. So here I'm generating the rows for this CSV file. So first, the archetype ID. The archetype ID, we are iterating here through all the archetypes, so I have that. The path, I am iterating through all the paths inside that archetype, so I have the path. Then I can ask the node for the reference model type. Yeah, these are the types in the reference model, so the node contains that. And checking the class of the node, I can take the type of the node in the archetype model. This will be the archetype object model type. Yeah, this value here. Yeah, and because some nodes don't have a node ID, I check if the node has a node ID, add the node ID to the row. Yeah, will be the node ID column. And then for all the languages, and this is a tricky part, what I do is I take the term definition. The term definition, if you remember the structure, term definition, if you ask for a term definition passing a language and a node ID, it will give you this object, basically. As an object. Yeah, this is the ADL format, but you need to come here, provide the language, so the language will be the key here, and then the node ID will be the key here, and it will be providing you this object. And this object contains text and description. So this is the object that I found, and I will ask for the text. So it will add to the rows. Yeah, remember these name columns are dynamic for each language here, so it will be Spanish, English, blah blah blah, the text, corresponding text. So it will put the text here, blah 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 blah, and then we'll process the next path here. So it needs to finish the row with a line terminator. So it will be beep, 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 doing that here. And since the archetype finishes processing here and then comes to the next archetype, I need to generate the output file here. So the output file will be putting the final file in the same path as it was reading the ADL files. I will set the archetype ID as the name of the file, and the extension will be just CSV. Yeah, and this is the way you create a file in Groovy, and this is the way you write a file in Groovy. So this is writing the header and the rows. Yeah, and header and rows are restarted when on the next loop. Yeah, so I start fresh. Yeah, and at the end it tells you, hey, I generated this number of CSV files. Yeah, so let's execute this thing. So what I will do here is first I build. There is a build script in the project, so it's easily done. Then I need to generate the jar file, so already done. And then I will close this thing here. Here we have only the ADL files, so I will execute. And the way you execute, you need to, this is called with Java because it's already compiled. So all the Groovy code is compiled to Java bytecode. So everything here is just Java. And the class path is the libraries folder. So there are some libraries there that I needed. Then the Groovy folder and the libraries there, you need to have Groovy installed for this to work, and that is very easily done also. And then it uses the jar that we just generated. Here is the main. This is just the main class that I just showed you. Is this code is this code. It's just this main class here, CaboLabs openEHR. Yeah. And what I do is CSV is the command. Yeah. And then I pass the path to the folder that that contains my archetypes. So it's just this folder. Yeah. So executing this, this processes, just prints out the arguments. It generated 21 CSV files, and you can see here we have a lot of new files. And each file, if I sort by name, you can see we have an ADL and a corresponding CSV file. And now if I open this, I can say this will be separated by comma. I have this. Yeah, this is exactly what I needed. Yeah, I have the archetype ID here, the path. So these are all the nodes in the archetype. Yeah, it will be a good maybe improvement to sort the paths so it goes in some kind of order. Yeah, I will do that. It's just a line of code. Then we have the reference model type here. Yeah, all these types are in the reference model defined. Then we have the archetype node type. Then for the nodes that contain the node ID, we have the node ID here. And of course, if those contain node ID, they will have translations or definitions. So I have here name in German, name in Russian, name in Norwegian, name in Portuguese, in English and in Spanish. Yeah, we have some translations to Spanish. And also you can see some the ones that start with the asterisk are nodes that are not yet translated. Yeah, so you can see that some archetypes have some failing translations. Yeah, this is not failing, but are just missing. Yeah, to complete, I will see. I will, like, if I wanted to use this archetype in Spanish, I will first translate the archetype and post that archetype to the CKN for review and approval, and then I will generate these CSV files. Yeah, I will wait for that. So this is a good way to check if all the nodes contain translations for the languages that you want to use. Yeah, so this is exactly what I needed. And what I will do later is I can add columns here, for example, and I can say table ID, table name, column, and maybe type. Yeah, and this will be my types or the types in my database. Yeah, and this will be divided here, like, I'm not a good spreadsheet user. I just do healthcare informatics, so I need someone that knows really this stuff. Yeah, so I will do something like this when I do data mappings, and data mappings is something that I do very often. So column, good. Take the type. So yeah, and this should be at the top, of course. Yeah. So I will put here my model, and I will start like marking, this corresponds to this, something like this. So this is what I do in general. So I don't like this color. Yeah, something like this. And you might not have mappings to all the nodes. Yeah, because the archetype might be more complete than the data model that you have on your database. That is normal. The thing that can't occur is that you have more data than the one in the archetype. That means the archetype is has some information missing, or maybe it's not well designed. Yeah, but you need to check if your data should be really mapped to this archetype or should be mapped to a different archetype. Maybe you have information on one table that should map to two archetypes. Yeah, so it depends on how normalized is your relational model, really. Yeah, so that depends, and that is where the expertise and the experience comes in to realize how to do the mappings. Yeah, this is not straightforward and this takes a lot of time, but this tool is saving me really a lot of time on doing this stuff, and I did this stuff manually for I don't know, for some time, I would say. Yeah, but now I have a tool to generate these things. We might have another tool too. For example, if you use a relational model to export your relational model to a SQL dump, and maybe to parse that SQL and to generate from the SQL a CSV file. So maybe you can generate this CSV also, and then when you have the two CSVs, you start doing the mapping. That will really speed up the process. Yeah, but the process of mapping, that is difficult to automate. Yeah, because it requires some semantic analysis and semantic interpretation of the data to do the mappings in a good way. Yeah, I guess in the next years with artificial intelligence we will have more assistance on that area, but right now automatic processes are not good at interpreting semantics. Yeah, so mappings are not really something that could be automated right now. Yeah, but I wanted to show you just this small tool. It took me a couple of hours to figure out how to do this and to have something that actually works. It needs some improvements. Like I said, to sort the paths in the file would be a good addition, and I will do that next, I guess. So I will do that change, a couple of tests, and then I will upload the code. Yeah, so remember, the code will be available on my account and on this project. This will be my account, and will be let's go to my profile here. Yeah, you go to my profile and openEHR ADL. This will be available here. Hope you enjoyed this video. I like to share my things, my stuff, and if I think this will help a lot of people. And yeah, if you have any questions, just let me know. If you like this video, just like it and subscribe. See you later. Bye bye.